Dear students, I'm very happy to be in this class. You are most welcome. And today we are going to discuss water management in rice. How to manage the water, how much water to be applied in rice, when the water should be applied to rice. Scheduling of irrigation, I think you will study in one course on principles and practices of water management or irrigation. There you will learn that when to apply, how much water to be applied, and by what way or by what method water is to be applied. All these answers are given by irrigation scheduling. So today, so far water management in rice is concerned, we will discuss the various rice environment. They are already covered to you. Extent of water productivity, how much rice we can produce by water, by given quantity of water. Global rice water use, how much water is going towards production of rice. And of course, there is a scarcity of water. And what are the important reasons for scarcity of water in rice growing areas and how to overcome these problems. So so far water management is concerned, that will vary with the environment of the rice, in what kind of environment it is growing. Suppose it is upland rice, you will have different strategies of water management in upland rice because you are not applying any water. Then comes your irrigated rice. In irrigated rice, you have to manage water very effectively, very efficiently, because 2/3 rice is irrigated rice. Or so far in India, if we see data says that 60% rice is irrigated rice. So here, the main emphasis should be in this case, where we should apply less and less water to produce more and more. And then you can have lowland, rain-fed lowland areas. In those, you can't do much. Similarly, in flooded areas or submerged areas, you can't do much. You cannot take out water. You cannot drain out large quantities of water outside the paddy field, because all areas, a greater extent of area is submerged with water. So there is no place for drainage in flooded rice or submerged rice. So all these issues we are going to discuss. First of all, see the rice environments or rice ecosystems. You have already seen them. So broadly, they are upland rice, irrigated rice, rain-fed lowland rice, and flood-prone rice. So water management will vary according to the rice environment. So the major emphasis is on irrigated rice, lowland rice, irrigated lowland rice. So if we see the data in the world, it is about 79 million hectares of irrigated lowlands. That is 75% of world's rice production is coming from irrigated lowlands, or you can say irrigated rice. And average yield, I've already shown you, but range can be 3 to 9 tons per hectare. But on an average, you can say it is 4 to 5 tons per hectare or 4 to 6 tons per hectare average yield in irrigated rice. Mostly grown with supplemental irrigation in the wet season. So for seasons are concerned, you are aware of the seasons in India. Wet season is your rainy season. So in rainy season, most of the area it is grown. If you remember, 86% production of rice comes from wet season or Kharif season. So that is the major season. And in that season, in irrigated rice, the water management is by rainfall plus, or water supply is by rainfall plus irrigation. So one can go for supplemental irrigation during wet season. And significant areas of rice are grown in rotation with other crops. Now, what are the important irrigation systems? So let us see what kind of sources of water are there. What kind of sources of water are there for rice or for any other crop? You will have, a farmer will have almost 1 or 2 kind of sources of water for all crops, whether it is rice or whatever he has. So in most of the cases, you can have individual irrigation, individual pump irrigation from shallow tube wells. This is quite common in Punjab, Haryana, Western UP, Uttarakhand, some places, and Andhra Pradesh. So you got individual pump irrigation from shallow tube wells down to about 15-meter depth. Normally it is 15-meter depth, shallow tube wells. Tube wells, I think you know how farmers get the tube wells, and tube wells are run by electric motor or by diesel engine, or sometimes by tractor also. Farmers can run these tube wells. Small to medium scale community-based pump. Now certain community-based pumps are there. Some government pumps are there in villages. I know in some states, there are some community pumps. We call them Sarkari tube well, Sarkari tube well irrigation. And here you have from deep wells also down to 200 to 300 meters. So these are small to medium scale community-based pump irrigation system. Then small to medium scale community-based surface irrigation, where water is derived from pond or reservoirs. So many times some community-based ponds or reservoirs are there, where many farmers may have right to draw the water. So these kind of sources of water are also there in the country. A small to medium scale community-based surface irrigation, where water is directly derived from a river, runoff of the river irrigation. Sometimes rivers, water from rivers is also taken by farmers, and large scale surface irrigation where water is diverted from reservoirs or lakes or canals. So here you got canals also. So you get mainly two kind of sources, surface water sources and underground water. Underground water is pumped by tube wells, and surface water may be ponds, reservoirs, or maybe rivers, or maybe canals. Now see rice field and water balance. So what are the inputs and outputs in the rice field? So balance means how much water is coming and how much is getting lost. So water inflows, how water comes to rice fields, that is by irrigation, rainfall, and capillary rise. In many places, capillary rise has become very, very important. In upland rice, there is no contribution of capillary rise, but in lowland areas, many times this capillary rise contributes to significant water requirement of rice. And now what are the losses or outflows? Evaporation, transpiration, seepage, and percolation. These are the outflows or losses of water in paddy field. And water contributes to the growth and development of plant, some part considered as non-productive water losses. Only transpiration is the productive water loss from the field, like losses like by percolation, or we can say leaching or seepage. They are not productive use of water. So it is definitely important to decrease the unproductive use of water, unproductive use of water. Make the every unit of water as productive. Now see how this groundwater can contribute towards water requirement. So it is very, very important, particularly in the light of declining water availability. Remember, if groundwater is less than or shallow, if it is very shallow, less than 20 centimeter deep, hidden source of water to rise during winter months, or sorry, during wet season. Roots extract the water. Means you can see the rice roots are restricted mainly to 30 centimeter upper layer, so they can get this capillary water. If fields not flooded, capillary rise may reach root zone, provide extra water. Means in case of water shortage, it is important source. With shallow groundwater, crop growth with little irrigation can still grow well because of the hidden water supply. So this is important. We have got certain areas in our country where water tables are very, very shallow. We have areas where water table is very, very deep. In Rajasthan, in dry areas, some other parts, water may be up to 200 meter, 300 meter or more than that. But in some places like Tarai, regions of Uttar Pradesh or Uttarakhand, in wet season or in rainy season, you can have almost zero level of water, groundwater. Maybe 5 centimeter, 10 centimeter, you can get water. In some places, during rainy season, people just remove the soil and water oozes out, water comes out. So lot of variability is there in water table. But wherever water tables are shallow, a good amount of water can be extracted by rice. Now come to the rice productivity or rice water productivity. So many times we get confused about water productivity and water use efficiency. So water productivity is a very big term, and water use efficiency is part of water productivity. Water productivity in simpler terms is productivity of water. We have applied such quantity of water, and that quantity of water, how much is producing. That is rice water productivity. Other thing is consumption of water, actual consumption of water for producing the grain. So many times you cannot avoid ET losses, evapotranspiration losses, which is also considered as consumptive use of water. Consumptive use of water, and that is your means grain per unit of ET is your water use efficiency. And water productivity we can calculate based upon the quantity of water applied. How much water applied by irrigation, how much water applied by rainfall, and how much water is applied by rainfall plus irrigations. So that will make your water productivity. You will get more clear just in 2-3 minutes. So rice water productivity improvement is very, very necessary, and it is a challenge to produce more food with less water. I think you know Prime Minister Krisi Sinchai Yojana, where they have got slogan, more crop per drop, means you want to produce more and more with less water. And system performance should be evaluated in terms of both water use efficiency and water productivity. Water productivity is a concept of partial productivity, and denotes the amount or value of rice grain over volume or value of water used. Water productivity is equal to value of rice grain in kg per hectare. So this is the value of rice grain, maybe in terms of economics also, maybe in terms of kg per hectare also, divided by value of water use, means how much water is applied, cubic meter per hectare. So you can easily convert cubic meter per hectare to liters or other units. To avoid confusion and interpretation in the computation of water productivity, it is important to clearly specify the differences. Now you can see water productivity. So rice water productivity is considered as partial water productivity. Partial means you have 2, 3, or 4 different kind of rice water productivity. So if they are calculated separately, one by one, then individual is your partial rice water productivity. For example, if you apply nutrients, nitrogen, phosphorus, potassium, and if you calculate productivity just for nitrogen, then it is partial factor productivity. If you calculate only for phosphorus, it is partial factor productivity for phosphorus or potassium. You can work out productivity of individual nutrient, then it is partial factor productivity. And when you combine all the inputs, together, then it becomes total factor productivity. So there is difference in partial factor productivity and total factor productivity. So here we have different partial factor productivity or partial water productivity for rice. So number one is WPT, water productivity of transpiration. So weight of grains over cumulative weight of water transpired. How much water is transpired? So this is also called as transpiration efficiency, means grain produced divided by quantity of water transpired. Then your water productivity ET, Now your evapotranspiration is also there, which is actual quantity of water consumed by the crop. So this is weight of grains over cumulative weight of water evapotranspire, ET. So actually this ET is your water use efficiency. It is your water use efficiency. So you can see here for clarity that water productivity is measured with respect to WPT, WPET, WPI. I is for irrigation water, water supplied through irrigation, and then WPIR, water supplied through irrigation, plus R is for rainfall. So you can see this water productivity in 4 different respects. And out of these 4, one is your water use efficiency, which is WPET. Now you see WPI, rice water productivity with respect to irrigation. So weight of grains over cumulative weight of water inputs by irrigation. Here you do not include water that has come through rainfall. Just you consider the quantity of water coming through different irrigations and divide the yield by that quantity of water. Next is your WPIR. This is irrigation plus rainfall. So weight of grains over cumulative weight of water inputs by irrigation and rain. So here your grain produced divided by water supplied through irrigation and rainfall. So this is how you can make difference in water productivity. So water productivity is a much broader term which includes 4 kind of partial water productivities like WPT, WPET is your water use efficiency, WPI, WPIR. So in this case, overall water use efficiency is very, very important. Many times questions are asked on water use efficiency. So it is your yield divided by ET or consumptive use. So in this case, many times how to increase the water use efficiency, there are 2 ways. One is you increase the yield. So yield can be increased by selecting proper varieties, proper cultural practices, and good management. So one way is to increase the yield. Other way is to decrease the ET. But if you go on in increasing the ET, then your yield will decrease. So to the best extent possible, one can reduce the ET to the level that yield is not affected. So there are some methods to decrease the ET, to reduce the ET losses also. So this is how one can increase the water use efficiency, by increasing the yield or by decreasing the ET up to the extent where yield is not adversely affected. Any point of discussion, anything which is not clear to you, if you want to discuss, because then we move next. Yeah, Dhyan, you have any questions? Satyam?
No, sir.
No, sir.
Is it clear, water productivity and water use efficiency?
Sir, please explain one more time.
Okay. So water productivity is much broader term, which primarily focuses on the grain produced or biomass produced per unit of water applied, actually, per unit of water applied. And water use efficiency mainly focuses on use of the water. What proportion of water, whatever you have applied, what proportion of that has been actually used by the plant, and how much grain is produced per unit of that actually used water. So in water productivity, it is sum of, or it is partial factor, no, partial water productivity. Several partial water productivity can be worked out with respect to rice water productivity, like water productivity due to transpiration, quantity of grain produced divided by quantity of water uh, used in transpiration or lost by transpiration. So you can calculate that water with respect to cubic meter or hectare meter or hectare centimeter. You can get different units, or liter. liter in water applied, liters of water applied in 1 hectare. So you can use any unit of water used. Then WPET is your water use efficiency. Here your yield produced or biomass produced is divided by ET, consumptive use. So this water productivity is your water use efficiency. So the water productivity includes your water use efficiency.
Sir, please repeat the unit of water use efficiency once again.
Okay. Water use efficiency or whatever efficiency you are working out, whatever productivity you are working out. So all water is always denominator. Numerator is on the top of line and denominator is below the line. You know this 1 divided by 2. So 1 is your numerator and 2 is your denominator. So this denominator is always water. And this water can be water that is used in irrigation, water that is coming by rainfall to the field. It can be reported in different unit. Number 1 unit is hectare centimeter. Hectare centimeter means you got 1 hectare area. In that 1 hectare area, the height of the water is 1 centimeter. So then you convert this 1 centimeter to meter. 1 divided by 100, it will be 0.01. This 0.01 can be multiplied to 10,000 because that is the area of 1 hectare. And whatever you get, that is the cubic meter water in 1 hectare. Cubic means length, breadth, height, you know. So in that case, length, breadth is 100 by 100, 10,000 meter square area, and depth of water is 0.01 meter, or whatever unit you have. You can have meter also. So then very easily you can convert it to cubic meter. Quantity or volume of water is cubic meter. And 1 cubic meter of water is 1,000 liter. Am I right? 1 cubic meter water is equal to 1,000 liter. Is it correct?
Yes, sir.
Okay.
Yes, sir.
Okay. So then you get the quantity of water in 1 hectare in liter also. Then yield divided by quantity of water. So similarly, you can convert the yield starting from tons, you can convert to kg, you can convert to gram, depending upon the unit, depending upon the number of the unit. If it is large, then you can represent in ton. If it is small, then you can represent in gram. For example, gram per liter. It is many times people report milligram per liter, depending upon the crop. So that is how we got water units. Now coming to what WPET is your water use efficiency, then WPI. This is kind of water productivity, yield or biomass divided by irrigation water applied. What quantity of water is applied? Similarly, WPIR, irrigation plus rainfall. So that is denominator and yield or biomass is your numerator. That is your water productivity, IR. Now, water used by rice. How much water is used by rice? So estimated ET of all rice field in the world is 859 cubic kilometers per year. That is the ET losses. Only ET losses by rice crop in the world is approximately 859 cubic kilometer per year. You do not bother about this figure. This is just to show you the extent to which water is evapotranspired by rice in the world. On an average, 1,432 liter of ET to produce 1 kg rough rice. This is important. So this much of quantity of water is required to produce 1 kg rough rice. 1,432 liters. These figures have been varying with the people who are reporting it. So sometimes you will find people say 3,000 to 5,000, sometimes 1,000. So these values are changing with the person reporting because conditions may be different. Your climatic condition, soil condition, variety condition, all these conditions may be different. Therefore, this variability is reported by people. But you can remember this 1432 also liters of water. This is roughly the same as world average water use of wheat. So ET value for wheat is also same, but higher than that of maize and barley. Maize is C4 plant, therefore water use efficiency is higher in maize. It can produce more grain with less water compared to rice or wheat. Now, comparison of water productivity in different seasons and locations, not good. Just I was discussing about it. You cannot compare the water productivity of seasons and locations. So because your climatic changes or climatic scenario will be altogether different. In wet season, in rainy season, you will get more contribution from rainfall. You will have more humidity. You will have higher temperature, and number of variables will be different. And in another season, dry season, you will have different variable. Therefore, you cannot compare the water productivity of one season with other season. Mainly because of differences in supply of water. If you go on increasing the supply of water, then water productivity declines. If you reduce the water supply, then normally water productivity increases. So comparing water productivity among seasons and also locations can be misleading because of differences in climatic yield potential, evaporative demands from the atmosphere. Under two locations or two seasons, you can have different evaporative demands. You can have changes in crop management practices also. It is more relevant to study what the potential and actual water productivity values are in a particular environment, in a particular season. So we can identify measures to close the gap between them rather than to compare water productivity values across environment. So that is just to save the water, to reduce the water input so that we can improve all kind of water productivities. Now see global rice water use. You can see extent to which global fresh water is going for the cultivation of rice. So irrigated rice receives some 34 to 43% of the total world's irrigation water, or 24 to 30% of the total world's fresh water withdrawal. So you can see 1/3 of the fresh water of the world is going to rice. You can see very large quantities. On x-axis, you have water, cubic kilometers. On x-axis, you have different. So welcome back in the class. I'm sorry for disturbance. Now you can see 1/3 of the world's fresh water is going to rice. So you can see world water withdrawal is very large, more than 3,500 cubic kilometer, out of which roughly 2,500 is used for world water use irrigation. And whatever water is used for irrigation, a large part is used by rice crop. So you can say it takes lion's share in water use. So you can get data on this. Now you see water scarcity in rice growing areas or environments. So two types of water scarcity can be there. One is physical water scarcity. You might be knowing what is physical water scarcity. Means water is not available. There is no presence of water. So you can see certain areas, red areas, which have physical water scarcity, areas in red in the world. Other is economic water scarcity. Water is there, plenty of water is available, but it is expensive. The user will reduce the use of irrigation to cut back the cost. You do not have money to buy the water. So that is in yellow areas. You can see in yellow areas. And blue areas, I think they are sufficient, self-sufficient in water. There is no scarcity, any kind of scarcity. It is mostly developed world where there is no scarcity. It is in Africa or Asia where we have water, both kind of water scarcity. Now, forms of water, you must be knowing different forms of water. You prepared for your entrance exam. That time you might be knowing what is available water, what is unavailable water. So you can see when you apply irrigation or when water comes through rainfall in the field, so flooding condition can happen. And then the leaching or percolation of water start. The gravitational water, that drains from the field down, reaches the groundwater. That is gravitational water. When you have flooding condition, the moisture content or potential is 0. And when the water is drained by gravitational force, then comes your field capacity at 1/3 or 0.33 bar moisture tension. And then up to 15 wilting percentage, your water is available, which is known as available water. And after 15 bar, water is very tightly held and it is unavailable water. So this is very simple terminology of forms of water you might be knowing. Can anyone tell me what is field capacity? Yeah, Krishna Patidar. What is field capacity?
Sir, the amount of water which is retained in the field is known as field capacity.
It's retained in the field after flooding it. After flooding
Yes,
it,
sir.
with the drainage of water from 24 to 36 or 48 hours, something like that. Then the quantity of water means it is the maximum limit of water that can be held by a soil. That is your field capacity.
Yes, sir.
That is the moisture percentage, maximum quantity of water that can be held by a soil without any standing water. That is your field capacity. So
Yes, sir.
now we will see what are the practices for water management. As in the very beginning, I told you, water management practice will vary with the kind of rice environment. In upland rice, in lowland rice, in your flood-prone rice, you will have different practices of water management. So what happens when water management practices in lowland rice? First, we look for lowland rice. So there can be many kind of water management practices. Here, conventional water management aims at keeping the fields continuously submerged. So it is for irrigated lowland rice. Conventional aim is to keep the fields continuously submerged. Initially, a shallow layer of 2 to 3 centimeter, but with time, the water depth is increased to about 10 centimeter. After transplanting, you can maintain 2 to 3 centimeter layers of water, but after that, one can go up to 10 centimeter. But this is subject to availability of the water. In conventional rice culture, CRC, means your traditional farming, which is transplanted puddle, large losses of water by evaporation from the water surface and by vertical percolation below root zone. So in conventional rice culture, you are applying large quantity of water, you are flooding the soil, therefore the losses of water are also high. So these water outflows do not contribute to crop growth and are therefore called unproductive. So in this case, there is a lot of unproductive water in case of flooding irrigation or in case of conventional rice culture. Larger quantity of water are removed by percolation or seepage. So there can be 3 kinds of losses from rice, lowland rice: seepage, percolation, evaporation. And these are unproductive losses, can be minimized through sound field water management strategies. So there are a number of ways, number of strategies to reduce water losses by seepage, percolation, and evaporation. So how we can reduce the non-productive water losses, seepage, percolation, evaporation? Proper land preparation practices. So proper land preparation practices like your puddling or land leveling, they will help in reducing the non-productive water losses. Then comes the crop establishment or planting technique. If you remember, we also discussed strategies for saving water in rice. In those lectures, if you remember, we discussed about different crop establishment methods and planting techniques. And we have also discussed that there were certain techniques, certain crop establishment techniques that can reduce the water use or that can reduce the losses of water. We have seen aerobic rice or direct seeded rice. We have seen SRI. We have seen GCRPS. We have also seen ground cover of this saturated soil culture, SRI, and so many different methods of establishment. So if we are short of water, we can go for those kind of establishment, crop establishment method. Crop establishment means sowing, how to establish the crop by sowing or planting. Besides this crop establishment method, we can use some efficient water management practices. Water management practices which supply sufficient water to the crop. There is no any deficiency of water, but with less water. So those kind of practices are efficient water management practices. Efficient cultural practices during the crop growth. Certain cultural practices can also help, like weed control. If you control the weed, your water losses can be reduced. So similarly, there can be many other cultural practices that can increase the water use efficiency. Now, for example, land preparation, how it can help in saving the, reducing the losses, water losses from paddy field, construction of field channels. So field channel preparation is good idea. If you want to apply water, then apply through channels. Many times what happens if you have larger areas, so farmer will apply, first he will apply water to one field, and from the same field he will connect to the another field, to the another field, and suddenly suppose his water supply is cut due to electricity issues or some other issues, then again he will restart from the field 1, then field 1 to 2. So better to have some channels, irrigation channels, so that individual field can be accessed or can be given water directly. So field channels are useful, and the same channels can be used sometimes if required for drainage of water also. Good land leveling will definitely save your water. It will reduce your percolation losses, because unlevel, undulated land, runoff is more, and also your water will impound in one particular area and other area may remain dry. So that way water height in low-lying area will be more, therefore percolation losses will be more. A good puddling can help in saving the water. Proper bund preparation, your bunds are broken at several places, then water can outflow. It can go outside the field. So bunds are also important. So I think almost all of you might be knowing the value of the bunds around the field. Crop establishment method, just I told you that different crop establishment methods require different water management strategies. So it is by choosing the most appropriate method given the water availability that you can save water. So here the message is, depending upon availability of water, one should choose the method of growing rice or method of rice crop establishment. So first of all, farmers should assess that how much water is available for applying to the rice crop during a particular season. So according to that, he should choose the method of establishment. If sufficient water is there, free water is there, and excess water is there, better to go for transplanted, puddle transplanted, conventional rice culture. If a scarcity of water is there, less scarce, then go for alternate wetting and drying. If it is too scarce, then go for aerobic rice or direct seeded rice. So many options are available. Now see what are the different irrigation irrigation strategies and methods. So this is overall what you can see, different irrigation methods in rice. And these are efficient water for efficient water management. So number one is, you can see in green, flooding irrigation and non-flooding irrigation. So if you see flooding irrigation, flooding you understand means you just indiscriminately you apply water to the field, impound water of 5 to 7 or 8 centimeter in the field. That is your flooding irrigation. So flooding can be of two kinds. One is continuous flooding, means your soils are always having your standing water in the field. That is your continuous flooding. Intermittent flooding means for the time being, your soil is flooded with water, and then the water will disappear from the surface and then you apply water. So that is your intermittent flooding or cycles of flooding and dryness. That is intermittent flooding. The next method is non-flooding irrigation. Non-flooding irrigation. Here you do not guarantee, you do not keep the standing water on the soil. That is your non-flooding irrigation or aerobic rice. It can be practiced in aerobic rice. So there can be unspecified irrigation method. We will see what is meant by unspecified irrigation method, and then other irrigation methods. What are different other irrigation methods for aerobic rice, or wherever it is not possible to maintain flooding condition. So you have got some other irrigation methods like drip irrigation or your sprinkler irrigation. So here you can say some scientists like Monaco and Sali, 2018, they have studied the literature. So this is study is done by these scientists on different methods across the world. So you can see these are the methods: continuous flooding, intermittent flooding, and other irrigation method. And some irrigation methods were unspecified. They were not sure what method of irrigation, water management is being practiced. Now you see 4 different methods. One is flooding irrigation. So it can be continuous flooding. Field remains submerged for the largest growing period, except for brief periods to allow fertilization or herbicide. Means most of the time soil is having standing water. Water is applied either immediately after tillage operations or after soil seeding of rice. Then intermittent flooding. In this, no permanent water depth maintained, alternately submersions and drying periods. So this is you're doing whole growing season. But during flowering stage, there should not be any shortage of water. Here, AWD, alternate wetting and drying, SRI, and semi-dry cultivation. So in these kind of methods of rice establishment, you practice intermittent flooding. So you can remember in case of rice water management, there is no one straight answer. If somebody asks you that how I can manage water in rice or irrigation management in rice, so answer is not that easy. You have to give, first you have to give that there are different establishment methods of rice, and water management varies with the method of establishment. For flooded or puddle transplanted rice, or for aerobic rice, direct seeded rice, SRI, or AWD, alternate wetting and drying methods, or you need to use different water management practices. So we will, in brief, we will see how water is managed under different crop management practices. Number 3 is unspecified irrigation methods were also there, means they have reviewed certain papers, and in those papers, the method of irrigation was not mentioned or were not clear. So no water layer is maintained on the field. This is one. Irrigations are applied periodically or whenever needed, at the appearance of soil cracking or at predefined soil moisture tensions. So in some cases, water scheduling is done based upon the soil cracks, particularly in aerobic rice. In aerobic rice, it is suggested when you get when you get very thin cracks on the soil surface, then you can apply water. Before these cracks become wider, they become rills, you should apply the water. Other irrigation methods, no water layer is maintained on the field. In this case also, irrigation water is applied periodically or whenever needed by sprinkler, drip, or furrow irrigation system. So here, other irrigation systems are mainly your drip system, furrow system, and sprinkler system. Now, irrigation water productivity, that is just 2 minutes more. Irrigation water productivity is measured here, kg per cubic meter water, kg of grain of rice per cubic meter water under different water management options based upon 51 published papers. So you can see continuous flooding. the water productivity is very low. It is just 0.99 kg grain by applying 1000 liters of water, because 1 cubic meter water is 1000 liter of water. So here in continuous flooding, you are applying large quantities of water, but getting less grain. Then intermittent flooding, you are getting 1.27 kg grain by applying 1000 liters of water. Similarly, aerobic rice irrigation method unspecified, you are getting 1.67. The last case you can see aerobic rice irrigation method is specified. So here it may be your drip system where you are getting 3.49 kg of grain by 1000 liters of water. Next column, you can see how much water is used in different methods of water management to produce 1 kg rice. So continuous flooding, you need highest water. 1010 liters of water will give you 1 kg rice. If it is intermittent flooding, then 787. Aerobic rice, 599. And aerobic rice, just 286 liters of water can give you 1 kg grain of rice. So this is the message from this table. And this picture I have already shown you. It is productivity is all right, means water productivity is more in aerobic rice. Continuous flooding, you get least water productivity. But we also look into economics, and we also need to look into the total yield, the average productivity of the rice. So now you can see productivity is highest in the traditional lowland method. See this last orange color dots rectangle. Traditional lowland system, here productivity is highest, crop productivity, but the water productivity is least. So as you come towards left, your water productivity may increase, but your yield or crop productivity will decrease. So we need to make a compromise somewhere. If you want to have more and more productivity, then more water is applied. If you want less productivity, crop productivity, then less water is applied. However, in that case, water productivity will be more. So we need to find out strike a balance between water productivity and crop productivity so that we get the ideal ratio, and also economics will come into picture. So a lot of things are there that are not necessarily required to be discussed here.
Sir,
So,
if we follow SRI method, then water productivity and yield productivity both will be balanced, right?
yeah, it is theoretically, it is said that because yields in SRI are also high, but they are theoretically high, and definitely water productivity is more. So theoretically from that angle, yes, SRI could give you better productivity of both water as well as crop. That is true. But thing is that SRI is now not practiced. We got means I can't say much false results or wrong results or wrong method, but that is the situation that not many farmers are adopting SRI in India now. But your statement is correct. Any other point? Good morning to all of you. Yesterday, we started the topic water management in rice. So there are different ways and strategies to manage water in rice, but depending upon the quantity of water available and method of crop establishment, we decide the irrigation strategies or we decide the scheduling of irrigation. It mainly depends upon availability of water, climatic conditions, and crop establishment method that will decide the method of irrigation, the time of irrigation, depth of irrigation, and so on. So this was in brief. However, in general, if you reduce the water supply, yield in general decreases and your water use efficiency increases. If you decrease the input of water, yield generally decreases, but water use efficiency increases. So in this, we have seen rice environment and extent of water productivity, global rice water use, and reasons of water scarcity. So these were rice ecosystems, and we have seen some data, and different kind of water sources are available. Some are underground sources and some are above ground sources of water supply. And we have seen the balance of water in rice, input and output. And input are mainly irrigation, rainfall, and capillary rise, where water table is very shallow. And water outflows or losses were evaporation, transpiration, seepage, and percolation. And we have seen capillary contribution of capillary rise in some cases. And we have also seen rice productivity, rice water productivity, water use efficiency, water use by rice we have seen, and then comparison of water productivity in different seasons and locations is not good. We should compare, or we should see only in one season. Kharif season rice cannot be compared with Rabi season rice so far water productivity is concerned. And we have seen global rice water use, a greater quantity of water is diverted for irrigation. Roughly it is 30% of the fresh water going to irrigation. Two types of water scarcity. We have seen physical water scarcity and economic water scarcity. Forms of water, we have seen it starts from irrigation or rainfall, and then gravitational water, available water, and unavailable water. Water management practices in load and rise. We have seen what are the practices under conventional rice culture, and water losses by seepage, percolation, evaporation. And the purpose of water management should be to reduce the non-productive water losses like percolation or seepage, etc. What can be done? Proper land preparation, crop establishment, planting techniques, efficient water management, and efficient cultural practices. So these four can help to reduce the non-productive losses of water. Like land preparation, crop establishment method can be fixed as per the availability of the water. We have seen different strategies and methods of efficient water management. Flooding irrigation, non-flooding, we have seen 4 categories, and we discussed it. And perhaps somewhere here we stopped. So you can see in this picture, in this table, that continuous flooding, the water productivity, irrigation water productivity. This is irrigation water productivity. This is not total water productivity. If you take total water productivity, then it will be irrigation plus rainfall, water productivity, the total input of water. And in continuous flooding, it was just 0.99. Means you applied more water, but you get less grain. But in intermittent flooding, here you applied comparatively less water, but more grain, 1.27 kg per cubic meter or per 1,000 liter. Then if your method was aerobic rice and irrigation method unspecified, then this was 1.67. Aerobic rice irrigation method is specified, drip or sprinkler system. Here you can see the water productivity was highest. So roughly 4 times of continuous flooding, 3.49. And see water used to produce 1 kg rice. Initially, in case of continuous flooding, it is more than 1,000 liters, 1,010 liters. But in aerobic rice irrigation method is specified, you require just 286 liters of water to produce 1 kg of grain. So in this case, it is very simple that if you increase the water supply, the productivity of water or water productivity in rice decreases. Here, if you are reducing, if you are applying less water, then water productivity is more. But at the same time, you can see the total yield or average productivity per hectare basis. That was with respect to water supply, and it is with respect to method of cultivation. So suppose you see this picture on the right side, orange color, traditional lowland system. So here productivity is highest. The water use is also highest, means you require more water because it is continuous flooding. But here the water productivity is low. Similarly, you see pink color, this is for SRI. In SRI, you are getting yields, good yields, but less than traditional lowland system. However, water productivity here will be more. Similarly, yellow color line, this alternate wetting and drying, you are getting less yield as compared to SRI, but here productivity, water productivity will be more than SRI. Then aerobic rice system, least lower water supply, but more or high water productivity. So this is like this. Now see this table. This table is water balance and grain yield of rice as influenced by conservation technologies on a sandy loam soil at New Delhi. So you can see if it is continuous flooding. Continuous flooding has got three different methods. Methods of establishment. TPR is transplanted pudded rice. WSR is wet seeded rice. DSR is direct seeded rice. So you can see quantity of irrigation required. In TPR, it was 1360 millimeter. In WSR, it was 1108 millimeter. In DSR, it was 685 millimeter. See the ET. ET losses were highest in TPR and then less in WSR and DSR. Then percolation losses, you can see percolation losses were lower, very low if it was DSR and comparatively higher if it was WSR, wet seeded rice. But in transplanted rice, you got highest percolation losses. And then yield also. Of course, you got highest losses of water in TPR, but your yield was 5.5 tons per hectare. Similarly, in wet seeded rice, yield was 4. In DSR, 4.2. Similar yields in WSR and DSR. But if you see the water use efficiency, it was highest in DSR, 0.4 gram per kg water. And WSR, it was 0.27. And in TPR, it was highest 0.34. So this is how water productivity or water use efficiency varies. If you see the yield in wet seeded rice, you got 72% or 73% of the transplanted rice. Or similarly in DSR, you got, meaning is that you are getting lesser yields if your input of water is less. Water management during crop growth period. Now, how to manage the water under crop growth period? There are different periods of crop growth. If you remember, vegetative phase, reproductive phase, and ripening phase. So if your water is not limited, there is sufficient supply of water, you have huge water, then continuous ponding or flooding gives best growth and will result in the highest yield. So this is the conclusion. You will get a lot of variability in the data and in the results and in the opinion of people, but this is a matter of fact that if water is not limited, continuous ponding will give you highest yield in rice. Flooding also helps suppress weed growth. There are some added advantages of flooding, like it suppresses weed growth and improves the efficiency use of nitrogen, and in some environments help protect the crop from fluctuations in temperature. So this flooding has got several advantages, not just weed control and so on. It makes changes in the nutrient availability also. Except zinc, almost all the nutrients availability increases upon flooding. So it is good for nutrient supply. This and also it can moderate the temperature of the water, temperature of the environment. So how to manage the water during crop growth period? What can be done during early vegetative stage? In conventional rice culture, how to manage the water during early vegetative phase? So after transplanting, 3 centimeter water should be kept initially. Means at the time of transplanting till seedlings establish in soil. Because during this period, shocking seedling will be shocked. So therefore, a thin layer of 3 centimeters should be there. And gradually, with the time, it can be increased up to 5 to 10 centimeter depth. with the increasing plant height. So this is how you can manage water in early vegetative stage when you have conventional rice culture. If you have direct wet seeding, the soil should be kept just at saturation. No need to flood the soil from sowing time of at least up to 10 days after emergence. And then the depth of ponded water should gradually increase with increasing plant height. So initially in wet seedings, your seed is on the surface. If it is flooded, if you pond the soil with water, then seeds may rot. Rotting of seeds can occur. Then early vegetative stage in direct seeding, how to direct dry seeding, how to manage water in early vegetative stage in direct dry seeding. So soil should be moist but not saturated from sowing till emergence, as the seeds may rot in the soil. Same happens here also. After sowing, apply a flush irrigation if there is no rainfall to wet the soil. Means there are two cases. One is that if your soil is really dry, you can do pre-sowing irrigation and then do the sowing. Otherwise, if you are doing sowing in dry, immediately after sowing, flush the soil with light irrigation. So that will help in the germination in direct seeded rice. Saturate the soil when plants have developed 3 leaves and gradually increase the depth of ponded water with increasing plant height. So this is how you manage water under early vegetative stage in 3 different methods of sowing or establishment. Now, reproductive stage, almost same kind of water management across all the methods of crop establishment. So here, keep the water level in the fields at 5 centimeter all times. In reproductive phase means starting from your panicle initiation up to heading. Lowland rice is very sensitive to water shortage at flowering stage. If you have transplanted and lowland rice, it is very, very sensitive to water stress at flowering stage. Drought effects occur when water drops below saturation. Means your soil should be above field capacity. There should not be any shortage. If there is slight shortage of water at this stage, then the spikelet sterility can happen and crop will be affected most. So drought at flowering, it will result in increased spikelet sterility and decrease percentage filled grains, and overall you can see decrease in number of grains per unit square area, and finally yields will decrease. Now ripening stage means after the pollination and fertilization, your grain development start, and then in the end comes your ripening stage. So during ripening stage, presence of ponded water is not necessary. It is never necessary. So field does not necessarily require flooding during ripening phase. Soil that is 80 to 90% saturated is sufficient. Means soil can go below the field capacity and there can be 10 to 20% depletion of soil water. And this will not affect your grain yield and other yield attributes. For easy operations, keeping the fields flooded may still be the simplest management approach. However, it is not necessary. And also it is recommended that drain the soil 10 to 15 days before harvesting date. So many times it is recommended to drain out the water if there is standing water in the field, at least 10 to 15 days before the harvest. So it helps in, it hastens the maturity and grain ripening. So it brings your maturity slightly early without affecting the yield and prevents excessive nitrogen uptake. So the decreased water supply may help in preventing the excess nitrogen uptake, because this will not help in grain formation at this stage. Makes the land better accessible because it is drier for harvest operation. So definitely some people have to enter the field, or machine has to enter the field to harvest. So therefore movement of machine or people will be easier if it is dry. Now, another case is aerobic rice. We have seen direct seeded rice, bed seeded rice, transplanted rice. Another is aerobic rice. I already discussed what is aerobic rice. So under Aerobic rice systems, seepage, percolation, and evaporation losses are minimized because there is no ponded water layer and the large amount of water used for wetland preparation is eliminated. So already told to you that aerobic rice is high yielding rice where high yielding varieties are taken and the recommended doses of fertilizers are applied, fields are bundled, and sowing is done under dry condition, dry direct seeding in this. However, pre-sowing irrigation can be given and rice is grown just like maize or wheat. That is your aerobic rice. So far, water management is concerned in aerobic rice. So it is first you apply a less quantity of water so that soil gets wet and it immediately comes to the field capacity. So water, whenever we apply irrigation in aerobic rice, we should try to adjust the soil water to field capacity, not more than this and not less than that. So that is management of water. So here you need to apply a frequent irrigation, but depth of irrigation should be less. Now, see what is the difference between aerobic rice and upland rice. So you can see upland rice already discussed, just I read for you. Upland rice is grown in rain-fed, naturally well-drained soils with bundled or unbundled fields without surface water accumulation. In upland rice, there is never surface water accumulation. Drainage is very fast because water table is also deep here in upland rice. It is drought prone, planted in sloping land with erosion problems and with soils that have both poor physical and chemical properties. So soils are also poor whenever we take upland rice. They are not good in fertility and their depth may also be shallower. In case of aerobic rice, it is planted at more favorable environment where farmers can afford to buy external inputs, means pesticides, high yielding varieties, fertilizer will be used and can have access to supplementary irrigation. Water can be given by irrigation, but in upland rice, there is no irrigation. If rainfall is not sufficient, aerobic rice can be seen as favorable or high yielding upland rice. High yielding upland rice, it can be considered. Now, how is aerobic rice managed? So managed like wheat or maize crop. If the crop is grown during dry season, a light irrigation application should be given after sowing to promote emergence. Initially, when there is no moisture, so a light irrigation can be given. Weed control is done using herbicides. So this is your aerobic rice. Another kind of rice is your saturated soil culture, kind of SRI. How saturated soil culture saves water? So soil is kept near saturation. If your soil is kept near saturation, you do not apply extra water. So it reduces the hydraulic head of the ponded water. More the depth of standing water, higher is the pressure of hydraulic head. Lower the depth, lower is the pressure of hydraulic head. So it decreases the seepage and percolation flows. If you have more height of water, more weight of water, so percolation seepage is more. A shallow irrigation is given to obtain 1 centimeter of ponded water depth a day or so after the disappearance of ponded water. So in saturated soil culture, how to manage the water? You just apply 1 centimeter of, you apply such a quantity of water which maintains just 1 centimeter of water, and then it will disappear in 1 or 2 days. After the disappearance of this 1 centimeter layer of water, you apply the irrigation. Now you can see this picture, very interesting picture. It shows you how the percolation losses are high when your ponding depth is more. So deep standing water, see this picture. So percolation is high. See this blue color, the depth of water is more here. So percolation losses are more because hydraulic pressure will be more. See the next, the center figure, percolation is low here because depth of ponded water is very less than the previous one. So shallow standing water, you will have less percolation losses. See the last picture, no standing water, just saturated condition, very little water above the surface. So percolation is almost zero because you do not have excess water uh, that can be removed easily from the soil. So on the average, saturated soil culture can decrease water input by 23% from continuously flooded condition with non-significant yield reduction. So here, if you go for saturated soil culture, you need to apply frequent irrigation, but water saving can be done. The figure, saturated soil condition, no standing water, deep percolation losses is zero, while in continuously flooded condition, percolation is high. So higher the depth of ponded water, higher is the percolation losses. Alternate wetting and drying is another way of managing water in transplanted rice. This is generally practiced in transplanted rice, alternate wetting and drying. So there are cycles of irrigation and then you stop irrigation and you wait water to disappear from the surface. After certain days of irrigation or rainfall, water will disappear from the soil surface. So one can apply irrigation after 2 days of disappearance of water or 3 days of disappearance or 4 days. It can be up to 10 days, depending upon the soil conditions and climatic conditions. So alternate wetting and drying, AWD, is a water-saving technology in irrigated lowland rice. Irrigation water applied to flood the field a certain number of days after the disappearance of ponded water. A field is alternatively flooded and non-flooded. So this is actually very common practice in light textured soils of Punjab, Haryana, and some other parts, this alternate wetting and drying, because it is also not possible to keep the soils always flooded under those light textures condition. So it is a matter of compulsion also to follow this method of alternate wetting and drying. The number of days of non-flooded soil in AWD between irrigation can vary from 1 to 10 days. Means after disappearance of water, it can be 1 day, 2 day, or 3 day. A drying cycle of AWD, seepage and percolation losses are reduced because there will not be ponded water for every day. Every day, thus seepage and percolation losses are less than the continuous flooded. Compared to continuous flooding, it reduces water input by 15 to 30% without yield loss. So more about alternate wetting and drying. In areas where the amount of irrigation water available is less than the fully supply level required for continuous. So where we can use this alternate wetting and drying, particularly in areas where we have scarcity of water. Water is not available that freely as in case of conventional rice culture. In any irrigation system, to equitably distribute water and increase irrigated areas. Means through this alternate wetting and drying, we can save some water and that water can be diverted to other crops or other area. So in marginally irrigated areas, such as those at the tail end of any irrigation system and small farms reservoirs. So wherever there is less availability of water, I think tail end of canal or river, you understand. Tail end means river or canal gets originated from a place and it ends somewhere on the way. So the end and the last end is your tail of canal particularly. So you will see they get less water at the end of the canal. In areas where water supply is expensive, such as those in shallow and deep tube well pumps, irrigation system. So wherever you get less water, you can switch over to alternate wetting and drying. What are the principles of alternating wetting and drying? What are the things that should be kept in mind while scheduling irrigation by in AWD, alternate wetting and drying? So understanding the stages of plant growth is very, very critical of water stress, because here you will have cycles of drying and cycles of wetting. So what should be the right time for wetting and what should be the right time for drying, where some stress water stress can be given to the crops. So in this case, early vegetative stage, suppose it is early vegetative stage, then especially after transplanting to recovery period and reproductive stage. So two stages are very critical. Early establishment phase, where seedling is just establishing. So that time there should not be shortage of water. Your field should be flooded with light, with shallow depth of water. And of course, at reproductive stage, particularly flowering stage, is very, very critical. So in this case, keep your soil wet during these two phases. So during the first 10 days of the plant, the rice plant needs water. It is in this stage that it needs to recover. So water helps prevent and control weed also during initial period. So in alternate wetting and drying, there should be more frequency of application of water, or keep a shallow depth of water during the establishment of seedling. At flowering stage, water stress will result to spikelet sterility. Therefore, at flowering stage, the field should be flooded or saturated with the water. At ripening stage, there is no need to keep your ponded water in alternate wetting. So understanding of these stages is important in alternate wetting and drying. So there are certain benefits of AWD, alternate wetting and drying, saving of water by 15 to 40% without reducing the yield. There are a good number of data to support this, that by alternate wetting and drying, you get similar yield to continuous submergence. It reduces the cost of irrigation, particularly in pump irrigation systems, promote productive use of irrigation water, and increase the area that can be irrigated for a given amount of water. So it can increase the area because water saving will be there, and same water can be used to irrigate other rice field or other crops. Makes the rice plant more tolerant to water stress condition, because plant is facing little shocks of water stresses in this. So plant becomes tolerant to water stress. Correct some problems on soil nutrient imbalances like zinc deficiency. Zinc deficiency is more common in flooded soils. If your soils are continuously flooded, then you will have zinc deficiency. But if you have intermittent cycles of wetting and drying, then zinc availability increases. Increase the lodging resistance of the crop plant because of better root growth and aeration in the soil. Now, let us identify best option at different levels of water availability in the field. So just now we discussed different kind of water management in rice depending upon the method of establishment. We discussed about saturated soil culture, transplanted rice. In transplanted rice, you can go for puddled, you can go for continuous submergence or alternate wetting and drying. In aerobic rice, you have seen that water must be applied during early vegetative stage, and there should not be shortage of water at reproductive stage, particularly flowering stage. So this, and also these methods can save some water over conventional, a method of crop cultivation. Now, identify the best option at different level of water availability in the field. What are the best strategies of water management if you have a level of water availability, different levels of water availability? Means water is less, water is medium, or water is largely available, different categories of water availability. So it depends on type and level of water scarcity and on the socio-economics of their production environment. You can see in identifying the best option at different levels of water availability. Suppose number one option, water availability is very, very high. There is no any shortage of water and it is freely available. You are not paying much money for this. So practice continuous flooding of lowland rice and obtain high yield. So this is the option available if your high availability of water is there. Number two, when water is more than enough, it is just more than enough, water may be saved to increase irrigated areas. So what can be done here? You want to save some water here. So practice sound water management like crack plowing. Sometimes cracks develop, so they can be broken by some hoeing machine, or because it acts as a soil mulch. You can see it's kind of soil mulch. Thorough puddling can be done. Puddling helps in saving water. Good land leveling is necessary. Bund maintenance and construction of field channels to minimize water losses. So these practices can be followed and water can be saved. Farmer can practice water saving technologies such as saturated soil culture and safe alternate wetting and drying. These practices can be adopted. Farmers can adopt appropriate crop establishment methods, including direct or wet seeding and raised bed systems. So just we are seeing some alternatives to save the water in rice production. Now, third case may be with the water scarcity, more water scarcity, and farmers have little choice but to adapt to receiving less water. Anyhow, they are receiving less water than they would need it to keep their fields continuously flooded. So here options are: farmers can practice alternate wetting and drying in irrigated and aerobic rice technology in areas with supplementary irrigation or favorable rain-fed lowlands. Now, fourth option is when there is extremely short water supply, like in the rain-fed areas, farmer can plant upland rice varieties. So some varieties are available, of course, not in large number for all areas, but short duration varieties whose water requirement is less can be grown under water scarce environment. So you can see this picture is taken from Karnal. And in 1 year, in 2011, they had farmers have transplanted rice in soils, and then suddenly there was shortage of rainfall, because whenever rice is grown, it is not just 100% irrigation. Farmers believe, they trust that some rain will occur, and it is just combined supply of water through rainfall and irrigation. So there are areas where this rice is transplanted, and there may be scarcity of water because of a scarcity of rainfall. So many times farmers are bound to kill their rice crop. So you can see this is the situation due to scarcity of water in Karnal in 1 year. And you see they have allowed animals to graze their rice land. So because they were not knowing how much will be the water supply by the rainfall, there was no perfect, you can say, forecast of the rainfall. If farmers know that this year we will get less rainfall, exactly, because people make forecasts and predictions, but they will not hold true always. So therefore, situation may come where farmers are bound to destroy their rice crop, and they are feeding to animals. You can see such a situation also happens due to scarcity of water in rice production. So this ends this lecture here, and your questions are welcome.